Um, Welcome everyone to this Techloop about game development. So let's get started. Now, all of you surely at some point while playing video games must have surely wondered as to how they make them, and that's what we are here for today. Now, game development. Game development is the process of producing a game that involves various skills such as programming, art, design, writing, and various others. A lot of different aspects work together to bring the player a much more immersive experience. To put it a little simpler, a game developer is somebody that solves the problem of how to make a game. But what would you actually require to make a game? Hmm, Some of you might recognize the symbols that are up on the screen here. For those of you who don't, these are basically game engines. Now, what is a game engine? A game engine is a piece of software that takes care of functionalities such as graphic rendering, lighting, physics, audio, and various others. Now, there are many game engines out there that one can utilize in making the game. The most popular of which are Unity, Unreal, and Godot. A lot of video games and companies such as From Software and Valve also choose to create their engines from scratch. Now, for beginners out there, I would recommend using either Unity or Unreal to make games. Unity has a very beginner-friendly interface and has a huge community of support behind it. Whereas Unreal, if you want to go for something of a larger scale, it provides higher level graphics, so you can go for that. And it also provides visual scripting called blueprints. So for all the non-programmers out there, you can consider using Unreal. Now, some of the more popular games made using these two engines, some of you might recognize Fall Guys, which was made in Unity, and Valorant, of course, which was made in Unreal Engine. And for the students out there watching, you can take advantage of Unity's professional license that is offered at a discount for students. Now, some of you might feel that it is overwhelming to develop a game, but roughly developers usually divide it into three parts, which is scripting, art, and design. Scripting, uh, slightly more frustrating characteristic that goes into developing a video game. To explain it a little simpler, say I write on a piece of paper that says jump every 5 seconds, and I go and stick it to the back of somebody's shirt. Now, because of this paper, uh, the person will have to jump every 5 seconds. And this is essentially what scripts try to achieve. They program the behavior of a game object to work logically with other game objects. Now, some of the more popular languages used by developers are C Sharp, C++, and C. And if you're a complete beginner wanting to learn how to develop games, you can consider using the Pygame library of Python. Moving on to game art. Game art is the more creative side to developing a game. Anything from how your character looks to the VFX to the audio or the story of the game, essentially, is made by a team of game artists. Game artists are also tasked with the job of ensuring that their assets work efficiently on the hardware of the system that the game is essentially running on. A number of different tools are used in order to create assets for games, such as Photoshop and GIMP for 2D assets, Blender and Maya for 3D assets. And if you're somebody who's trying to make pixel games using pixel art, you can consider using Piskel. Moving on, game design. Game design is the part of game development where logic and creativity come together. So everything from how a level should look, or the mechanics on your character, or where certain rewards or loots are placed in the map, or where the enemies should spawn in the map, and countless other things are decided by game designers. They have to find creatively efficient ways to keep the player engaged while playing the game. Now, within games, there exists two types. 2D games and 3D games. Now, in 2D games, the player's motion is restricted to two axes, that is the x-axis and the y-axis. So movement is pretty much limited. Uh, but whereas in 3D games, you have more possibilities because they have added depth. So essentially, your character can move in all three axes, x, y, and z. Now let's move on to the hands-on part of the session. So, but before we even try to make anything, I would have to explain a little physics here. So speed. What is speed? Speed is basically the number of meters traveled in a second, and velocity is the number of meters traveled in a second in a particular direction. Suppose a body is traveling at 12 meters per second. That is the speed of the object, and its velocity would be 12 meters multiplied by the direction, which is minus 0.8, comma 0.6. So if you multiply these two, you'll get minus 9.6, comma 7.2, which means at each second, the body is moving 9.6 meters in the negative x direction and 7.2 meters in the y direction. Now, move amount. To figure out how much our character moves each second, we multiply the velocity with time dot delta time. Now, what is time dot delta time? Time dot delta time is essentially just the time elapsed between two frames. So if we multiply that with the velocity, we can figure out how much our character is moving each frame. Now, this metric tends to differ from system to system, but most games these days can run at 60 FPS. So time dot delta time for 60 FPS would be 1 divided by 60, which is roughly 0.017 seconds. So our move amount would be minus 9.6, 7.2 meters per second into 0.017 seconds, which is minus 0.16, 0.12 meters. So what this actually means is each frame, our character would have to move 0.16 meters in the x direction and 0.12 meters in the y direction. So let us move to Unity, where we can actually put this stuff into practice. So before that, I would like to show you the input manager of Unity. So the input manager basically takes care of your directions. So here, as you can see, the horizontal axis is left and right and A and D. So if you're familiar with the conventional WSD keys, you can figure out that A is negative X and D is positive X. Now, similarly, in the vertical axis, S is negative Y and W is positive Y. So you can also use the up and down arrow keys here. And why I'm explaining this is because later, while we're scripting the game object, we can use the method called getAxis, which I'll show you in a while. So yeah, so let's try and make a game object that we can control. So firstly, okay. So basically, this is the Unity layout. Before we move on to anything, I would have to explain what the Unity layout looks like. So this is our hierarchy. Our hierarchy basically contains everything that is present in our scene. So basically, the default Unity scene consists of a main camera and the direction light. And anything else you would like to add here, you can add. And here in our project, we can add our assets like audio, 3D assets, and materials, textures, anything else you would like to add is present here. Uh, Now, suppose we create a 3D object called a cube. Uh, it would come up in our hierarchy as I've explained before. And basically, what our inspector does is it gives us more detail about each object that is present in our hierarchy. So, suppose I've selected our cube here, it tells us different properties of the cube, such as the transform, the mesh filter, the mesh renderer, and the collider. This is something that exists with every game object. So let us bring our cube here to 0, 0, 0, which is the origin of the world in Unity. That's better. Now, with any game object, you will have three transforms, which is the movement, where you can move it anywhere you like, and the rotate, which is you can rotate it in any axis, and the scale. Again, in any axis you can do this, but I would like to keep it as is. So now, how do we control this game object? We do that using a script, as I've explained before. So let us go into our project and create a new C# script. Now, we'll just name it player for now. And to actually control the game object, all we'll have to do is drag this script here and attach it to the cube. So now, anything we write in the script will be applied on the game object. So we go into the player script. So as we open up a default Unity script, we will be greeted with this, the start method and the update method. This is common for any Unity script. The start method basically runs at the start of the game, as the name implies, and the update method runs every frame of the game. So it keeps getting updated every frame. So for our case, we'll not really be requiring the start method. So I'm just going to go ahead and delete that. So yeah. Now for the movement of our character, we would like to decide on a speed. So I'm just going to declare floor speed is equal to 10f here. 10f seems like a good amount for the speed of the character. Now moving on, we'll create a vector 3. Now what is a vector 3? A vector. So suppose our float, it contains just one value, which is 10f. But a vector 3 stores three values so that we can manipulate values in three axes, which is the x, y, and z. So for now, we'll create a vector 3 called input, which is a new vector 3. And as I've explained before, we can use our get axis method, which is in the horizontal for our in the x direction. And since we don't really want it moving up and down, we'll just leave the y as 0. And the z we can use get axis draw vertical. Now to see if this is actually working, I would like to print it out. So I'll just do print input. Now we'll save this, go back to Unity. Unity automatically compiles it, and if there are any errors, it shows up. So now we'll go to the console. Luckily, no errors for now. Let's run it. See. Okay, there is an error. Let's find the error. Okay, I forgot. Input get access. Input get access. So let's see if that works. So that error has been resolved. So basically, in our console, if there are no errors showing, we can continue. Now, as you can see, okay, you can't see it clearly, but when I press W on my keyboard, the Z is triggering to 1. And if I press S, it goes to -1. And if I press A, our x-axis becomes -1, and D, when I press, it becomes 1. So now we can clearly see that it's working. So, but that's not actually what we require. So instead of just printing it, let's try and move it. So in order to do that, we would have to declare another vector 3 called direction, which is basically our input, which is normalized. And if you remember, vectors that are normalized, so if a vector is from 0 to x values, when it is normalized, it basically becomes 0 to 1. So it would essentially be input dot normalize. Next, we would like to declare the velocity, as mentioned before, of the object, which is basically uh, our speed multiplied by the direction, which even in common physics, that makes sense. So we would like to take our speed and multiply it with the direction. Basically, speed plus direction is velocity. Next, we would like to declare the move amount, which is basically the amount of meters that it moves every frame. To the velocity into time per delta times. Now, next, all we'll have to do is control the motion of the object with the move amount. So, transform dot position plus is equal to the move amount. Now, hopefully, there are no errors. Let's just go ahead and enter it. There are no errors. So now we are able to control the cube on the screen, which is nice to look at. But I feel like our cube needs a little friend. So let's make another object. This time, let's make it something different. So let's make a sphere, and let's call it the chaser. And basically, what this will do is basically chase the cube as its name. Let us also define its position as the world's origin. Let's just move it here. Now, again, we would have to create a separate script to control the motion of the sphere. So go ahead, create new C# script. Let's call it chaser, and just drag it and drop it onto the sphere. Now, again, as you can see in the inspector, which shows all the properties of the game object, you can see that the chaser script is now attached just by dragging and dropping. Let's open up this script here. Again, we would not require the start method, so let's go ahead and delete that. Now, to define what our chaser is exactly chasing, we would require a reference to our player script. So let's go ahead and do that. We can do public transform target, and later we can go ahead and define that the target is actually our cube or the player. And again here, for the movement of our sphere or the chaser, we would have to declare a speed. So we can go ahead and declare it as 7x. We wouldn't actually want it to be equal to the speed of our player, because that would just make it weird. So again, we would have to create a vector 3. This time we would like to calculate the distance between the chaser and our player. So we just declare it as displacement to target, and which is basically our target's position uh, minus our transform the position. Now our vector, we'll have to create another vector 3 for the direction, as done previously before. Direction to target is equal to, again, it's just the displacement to target dot normalized. Which is it. And again, we have to do the same thing for the velocity is equal to our speed into direction to target. This time we'll be using a different method for moving our chaser, which is basically transform.translate. And we just have to give in our velocity and our move time. So basically, move time is velocity into time at delta time. Let's see if that works. We have another. Okay, translate is exactly. I forgot. Apologize. Okay, no more errors. But before we do anything, we would have to, as we can see here in our chases script, we have to give a reference to our target, which is the cube. So let's just go ahead and drag and drop. Everything in Unity is pretty much drag and drop. So now we can define our target as the cube. So let's go ahead and see if it's working. So as you can see here, as I move my cube around, the sphere tries to chase it. As my cube stops moving, as in I stop controlling the cube, my sphere just disappeared into the cube, which is not what we want. So let's go ahead and fix that. Now, to fix that, we would have to keep a kind of stop here. So let's define distance to target, uh, which is basically a displacement to target dot magnitude. Now, as you know, vectors come with two attributes, which is basically the magnitude and the direction. So we just take our magnitude for the distance to target and keep it in our distance to target. Now, if our distance to target is greater than 1.5, we would like it to stop moving. So we just put transform dot translate here. Again, capital T velocity into time dot delta. And we can remove the old command here, that is transform dot translate. This is pretty much it. Let's save that and go back to Unity. Okay, no error system. So we'll go ahead and see it. So as you can see here, now when I stop controlling my cube, it doesn't actually just disappear into the cube. Since we have defined that if the distance between the both of them is 1.5 meters, it just completely stops moving. So as I move it around here, when it reaches 1.5 meters, it just stops moving. So lastly, what I would like to do is, as you can see here, the camera is just pointing towards both of them here, and I don't really like that. So let's try and rearrange some of the things here. Using the transforms of the game object, you can move pretty much anything and rotate it a little. And I would also like to make a plane as so that both of these can exist. Right? Bring it down a little. And also, let's scale it up a bit. And white is actually really harsh on the eyes. So let's create materials. So all you have to do is right click here, create material. Let's make one for the players. Duplicate that. Another for the chaser. Duplicate it again. And another for the brush. And just again drag it and drop it. Player for the player. Chaser for the chaser. And ground for the ground. Now to actually change the color, we have to go here into the inspector, which shows again the details of the property, and go to here. And for the player, I would like to go reddish kind of color. And for the chaser, maybe green. Green. Let's go blue. And for the ground, maybe gray kind of color. So that's our end result. Let's test it out once more. So yeah. And again, since the inspector shows the even the characteristics of the script, we can change the different speeds and stuff of the object. So the cube and the chaser. And that's it for the live session. Let's go back to the cube. Now, for if you really want to become an independent game developer, I would highly recommend you check out this website called itch.io, where various indie game developers uh, upload the games basically. So if you're aspiring to become a game developer, I would suggest looking into this. And of course, we have IEEE's very own Notion page. The QR code for it is given here. So we have tons of resources, YouTube channels, Medium articles, and various other stuff that can help get you started. Uh, and happy game. That's it from my side. If you guys have any questions, please link it in the chat box. Thank you. Do you guys have any questions? Any questions regarding the live session also is fine. Are there any other engines for game dev? As mentioned previously here, we have many different game engines. Some of them are free, some of them are paid. All of these are game engines that you can use. Unreal, Unity, Godot, Game Maker Studio, Shiva, Cryo, CryEngine. Many of them, Amazon Lumberyard, of course, new into the game. You can use any one of these. It's really up to your preference as to what you would like to use. Yeah. So, if none of you have any more questions, thank you for listening. And I really hope you pursue game development as a career, as I have. It's a very interesting field, uh, and I hope to see you all making games. What are the job prospects for game developers? Uh, Game developers can make uh, really any number of jobs out there exist for game developers. But basically, as I said, it is divided into as such like scripting, art, and design. So as you go ahead with your journey in game development, you would likely see yourself inclining towards any three of these. So either you can do scripting, art, or design. But people who want to become independent game developers will actually have to do all three of these themselves. But mostly, if you're in a game studio, you would like to pursue either scripting, art, or design. Uh, that's it.